Okay. Hello. My name is Dalibor Dzurilla, and I use pink color because I think nobody will choose this color. Everybody will have dark presentations, so I make a little exception. But just for this slide, because it will be very pinky. So my main topic, what I will talk about, is how nature forces can shape architecture. It's my main exploring theme in architecture. What I study in Prague. The goal is to show how dynamic systems can help to effectiveness and for better design in architecture. There is many forces around us, like for example weather or noise, dust, wind, or traffic flow, or people flow, water. But some of these forces are invisible, and we cannot work with them in our digital environment where we design our architecture today. Some of these forces are stronger and more important for design of environment, but all of these forces are from physical world. So I started to interest how can I get them into a PC, and how can I use them for design. Because I feel that future generations is very important for us, and the main theme is sustainability and effectiveness, or future architecture. Because what we build now, 50 years later, will be still here. So I started to study dynamic systems, and what it is, I called it for all processes. What can be found in digital softwares. And I started looking for connection with real world. These processes describes nature elements like weather, gravitation, dexterity or flexibility in PC world. So I, as an architect, I become converter these values of physical environment and looking for digital values equivalent. This all finding and exploring of processes, I wrote a little thesis called Dynamic Systems, and it looks like a huge circle where is all dynamic systems collected and transferred into real element, nature element, and it could be folded into a little book, but also to exposed like big circle. So, and I just want to quickly show you one project. How can it be used, these dynamic systems? This is final image of my diploma project, the Thermae on island Štvanica. This island is on the pressure of all extreme elements like flood, traffic noise, and I would like to become this island, become oasis of calm, paradise for city, for Prague. So I studied these conditions of this extreme area, and I try to set up few rules for generative processes, analysis, for creating some guides and some borders for generating new geometry, for generating new volume on this island. And this island, this volume should become the future thermi, and also a biostructure for new trees, for new flowers, for new fauna. These rules was designed for better design, how I set up as an architect in physical world. For example, this is the picture of noise from roads, and this noise little deform my future volume, and for example the flute curves. I translate it into software and relax the point cloud to find where can I put the legs of this huge structure. This is the map of resting point cloud. A total process were 18 processes before final design was created. And all it's just start hypothesis to use how can we use the forces for design, the real forces in virtual space. This was generated and aesthetically edited in a final. In final, one segment was printed. Here is the choose one, and you could see it on a Biennale exhibition. For example, here is in exhibition in school. So remember why we do what we do. More empathic to environment, more sensitiveness in positioning and designing such static objects as building are. So thank you.
Okay, hello, my name is Jindřich Ráftl, and I study in Miloš Florián studio. Now I would like to introduce my project Relocation. And my project Relocation is about the station of the space elevator on the Earth. Okay, so here it is. It's it's a structure. And the structure, how we can see, it's something like a floating island which is able to growing into the space. Now I would like to say some few words about the space elevator. As you can see on this scheme, the concept for a space elevator was first published in the 1895 by Konstantin Tolstoy in Russia. And first some care or more care about from NASA and more developing of ideas. It will be start in 1959, and much more bigger popularization thanks to Arthur C. Clarke and his idea and his novel in Fountain of Paradise. Main idea of the concept is a made connection between the geostationary orbit, which we can see up there, and some base which can be on the equator. The idea is the same principle, like if you have a ball, and on the ball we have some rope, and the rope is on the equator, and when we rotated the ball very quickly, the rope will be straight and will be rotated around the ball. And this principle is able to use in every planet, everywhere in our space, and in NASA and another space agencies make a lot of designs around some towers on the moon, towers which can be everywhere else, or the space elevator, which I care about. So, in the elevator we need some rope, and this is my study of the rope. The rope is designed from 3 pieces. The pieces are, you can see, the growing fiber, helium stability systems, and the travel model, which is in the core of the structure. This rope should be something around 40,000 kilometers long, and it's a little problem made this structure on the Earth. So I use some idea it will be better for growing, and with the discussion with Miloš Florián, we made it from the growing nanobots, which will be intelligent and make some intelligent growing. It's better when you have something long like this. It's better because if you have in some piece of the rope some deformation on some broken process, the structure will be able to repair itself. This is only some sketch how it can be. Here you can see some helium balloons and some sections. And from the rope, if I finish with the design of the rope and the ideas, I start finding some more sophistication things in nature, and I care about the mushrooms and his mycelium. Now we can see the mushrooms have so many forms, so many edges of their structures, and so many systems how they can be connected between. It's something like intelligent systems, because mushrooms are not so much they are not too much able to socialize it between them, but there are some organs like Hlenka, I don't know how to call it in English, but it's something between the small organism and the mushroom, and they are able to make a lot of good connections and make some strong things. And the big opportunity for me was the Institute of Microbiology, where I find some friends, and I start there with a lot of laboratory tests, and you can see a lot of forms. I have studied a lot of difficult organics and things, and the greatest, which will be for me much more useful, is circular lastrivans. You can see on the left, in Czech we call it dřevomorka, and it's a mushroom which will be eat the buildings and eat the wood and every pieces. So it's a little bit dangerous, but he's really skillful how to use the environment around them. And this is my grow experimentation, my research. You can see in how it grows, and now I stand here in 20 June in 2013, and this is my new friend. And I tested on her a lot of things, how she's able to live in different environments, how is she intelligent, and what does he like or not. And from those things, I try to make some digitalization of their style of living. And I connect so many digital algorithms. Here you can see something a little bit basic. It's a system in so many steps. Then I connect the DLA brick system, and here are some linear, so I connect it together in one. And then also cellular automata, which make me some space and make some cubic things. And now I try to find some problems, or how the mushroom, which I have digitalized in my computer, will be able to make something like urbanism. Not something, but I have this algorithm is connected DLA with the cellular systems, and with some more agents, and I try to try to find some urban systems. So we can see there is the big white target. It's an elevator, and around them I take a lot of other things which my island will be thus. And now I run the script, and you can see how it grows, and more, and another step. And it will be more sophisticated, more difficult. And then, if I test this one, I connect the L system and another metaballs and make this structure, which will be able growing in the same type. And next step, and next step. And it will be growing and growing. And in some of part, I stop the script and check the structures and think what this can be. Yes, and now we can see the application. This is the floor plan of my floating island. The most idea was if I have something which is really new, something like space elevator, I'm not able to build something which is ordinary, like from beams and some irons and things like this. So this is everything made it from the intelligence carbon nanobots and covered by the biotic membrane. You can see how it's floating on the air. Oh yeah. This is a section, and you can see also the rope which going up. Okay, for me it's everything. Thank you for your attention.
Hello, I'm Tůma, also from the Flow Studio, and I want to introduce you my project Real, which is a space for double reality performance, and picking up the theme as well as what I do generally is influenced by the Laterna Magica theater group, which was founded in Expo 58 in Brussels, and the Laterna Magica became after the platform for the artists, scenographers, architects who established worldwide a new approach to the scenography through new media. And this platform was influencing another concepts like this, which is the theater study. It's treat about the variable and open space and takes the scenic space as a matter, as a substance which is modified by the performance itself. And another concept go further and says that the scenic space or scenic buildings are just a tool for the scenography, so you can do everything with them. And that also they should be prepared for the uncertain range of possibilities what will come, so that it should be prepared for unpredictable. And all this make a new radical loop of seeing the scenic space, which before it was you have a performance and it should have to be squeezed into the theater space, and after it loops and the theater space is formed by performance. So this was the first strong influence for my project, but I need a connection to the present, and I found it in a really special place in augmented reality. What you see now? Yeah, what you see now is the classical point of view to the scenic space, where you have some scenic elements in the space acting in time, and if you want to extend these possibilities, you have to extend it in. You are limited by this axis, and the matter still remains the same. The substance is the same. Each element acts its part, and the connection between them is a zero. So I think how to connect the element or how to extend the scenic possibilities by some other way, and I found solution in another dimension, which is a little bit virtual, and it allows me to connect all elements and create the augmented scene. It's really simple, but you have to just look to what happened in the stage, not like to the people or to the plot, but you have to look at it like to a data flow, which you can after modify it and play and work with this flow. So if you simplify it, it's just a simple input modification output system which receives data from the physical scene, after creates a virtual avatar like a modification, which means the virtual scene is created, and after, if you break the data to the same stage, you create the augmented reality or augmented scene, which was the point. So, but my purpose wasn't just think about the performance. I did it in the first half year. But the purpose was to design an object for this performance, which also is able to become the working platform for like indeterminate range of scenic actions. So I started. I was finding analogies of interactive and adaptable systems in nature around us, and what I found a simple cell. Simple organic cell, which all its life is interacting with inner and outer environment, and it has to adapt to survive. So, what was the most inspirative for me in the cell? It was the zoning, because if you compare the cell structure and the structure of scenic buildings, you have in case of a cell, you have some karyoplasm or nucleum, which keeps the essence of the cell, as well as in a scenic building. It's a scene with a performance like essence of this kind of building. And in a cell, the karyoplasm is enclosed by nuclear membrane. So I decided to apply this to my house as well. So I create something called inner interface, which I will explain it after. And what next? Next we have a cytoplasm, which itself has no function, but it creates the frame for the organelles, this stuff, which different functions, and the whole cell is protected by the cellular membrane in the outside. So going to the object in the scene, this is just like materializing of the process I showed you before, the input, modification, output. We tried in the half year with what we can know with the technologies what we have. So we was using the Kinect and some processing stuff, and we tested. And this is the application in ideal world of my theater, where the scene is just a white space, and all the components are integrated in the interface, or is done by the units, facility units around, which are not fixed, but they are floating. I will explain after. And they can adapt or change their position according to the scene demands. So you see some configuration that no, it's not just a theater with one rigid scheme, but you can have everything in this building. And what was for me the most important was the interface, because the demands which was to this interface was really hard. If I wanted to keep the scene void without anything, I have to integrate to the interface a lot of things like acoustic components, visual components, which is done by OLED display. Or it has to react to the inner and outer environment, like to the structure of bearing 3D grid or the demands of the scene. It has to be able to become whole and wall in the one time. So I make all this scheme to decide what system I will be using. But after analyzing the kinetic systems, I decided for the origami systems, and I developed my own configuration, which is really simple, but it has a big range of variabilities or configurations I'm able to use, and as well as able to be mapped on a sphere. And it also communicates with a raster of 3D grid. So it seems to be ideal for my project, but the big range of the configurations, like this, without control, it's anything. So I divided the systems into the 3-degree hierarchy to be able to control it, and for my project I control it by use the grasshopper script, you see. And now we get to the 3D grid. This is not my picture. Of course, this is the Archigram's control and choice project, which was influenced me during all this project, and also during the design of the 3D grid and the facility unit that looks like this, and it has a really simple form, or really simple cubic form, but what is the goal is that the units are floating in this grid on the magnetic levitation you see here, which is integrated in the units and the grid as well, and the grid becomes the same way like the cytoplasm. It has the lining of the energy of the data, and it connects all these units and support them. And finally, if we go back to the object in the center is a scene with the interface around, and the grid in fact is just the surface of the cube in one layer, which is duplicated in the corners. So that's why I was able to use the Floyd-Warshall algorithms to find like to control the movement of the units, not to crash themselves or to make it more organized. And the units look like this. That it's a simple box, but they are variable. They have the same for all units. Is just this skeleton with integrated maglev, the magnetic levitation system, and the flooring, and the hubs for connect them between each other or with a space or interface or whatever. And you can change what is inside. You can have their office, or you can have their auditorium, or you can have a performance there. So you can modify the cube the way you want. And this is a detail of the cube in a structure. And now I want to get back to the theme with the cell, because it's really obvious here that here you have a scene with the interface which is kinetic, and these beams are the 3D grid with the units inside, and the outer envelope of the building. So the concepts work well. Now this is the outer interface, which use also origami system, but much easier than inner interface, and it's also it protects the building, of course, like any other building envelopes, but it's also interactive by two ways: by visual, that it can open and you see inside how everything's moving. You have the visual contact, or you can use it like a screen. And the system is created for the simple origami units called water bomb. Is the simplest origami in a field, which react to the attractors, which can be like Dalibor mentioned, the weather, the climate, the noise, the point of view, or the inner environment demands. And obviously this building is something different than the guys before. It's too rigid and too cubic, but it was the purpose. I wasn't for finding the form. It's not about form finding. It's about the functional scheme finding. For me, was important the performance, not the building itself. It has to be neutral. But if you look at it closer, it's not boring. It's organic enough, because everything is the inner interface, the scene with all these augmented systems, and the facility units. Everything is moving, and the picture of the building is still different. And the functional scheme is also different according the scene demands, according the performance, and I find the organic in the life of a building, not just in a form. I think this is the big difference, and finally inside it's organic enough, I guess. So thank you for the attention, and this is everything from me.
Thank you for